Hello everyone, how are you all? I am Siddharth Kumarja and I welcome you all in this lecture. So in the today's lecture we are going to talk about the linear algebra for machine learning and in this session we will go through the vectors and matrix and their operation and how they directly connect to the machine learning problems like data sets, weights and the prediction. So first, we will go to the notepad and understand the basic introduction part for the today's video, and then we will come back to our slide for the further communication. Okay. So let me go to the notepad first. Okay. So machine learning relies heavily on the numbers and operations, as we know. So Uh, linear algebra provides the mathematical language for representing and manipulating the data. Okay, let me write it down. So linear algebra uh, provides the provides the mathematical languages and languages for representing and manipulating manipulating your data. Okay, so in machine learning, data in machine learning, your so data data is stored as matrix, as we know, like rows is equal to sample and columns is equal to features. Okay, so your parameter is like parameter. So when someone talk about the parameter, so it is nothing but the weights. Okay, so it is stored as vectors or matrix. Okay, and when we talk about the prediction, so in the prediction, like computed via matrix and vector operation, vector operation. So without the linear algebra, we cannot understand like how the models represent data or perform the computation. So I hope you guys had little bit understanding of the linear algebra for the machine learning. So now we will move to the second part, which is vectors. Okay, so vector is simply an ordered list of numbers, often representing data points or features. For example, a student marks in three subjects can be written as a vector like 85, 85, 90, and 78. So this is nothing but your vector. So we will discuss in this vector like vector addition. So we can add two vector element wise, okay, and scalar multiplication. So in the scalar multiplication, multiplying a vector by the number scale it, okay. So in the scalar, we are like multiplying 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 a vector by what? A number of scales. Okay. So the next one we will talk about the dot product. So this is the operation measures similarity between the two vectors. Okay. And in the last we will talk about the norms. So it gives the length of the magnitude of a vector. It is useful for measuring distance in machine learning. Okay. So I hope vector is clear, like basic understanding of vector is clear now. So we'll go to the notepad for the detailed explanation for this. So, so when we talk about the vector, uh, so a vector is a ordered list of number. Okay, so let me write down the topic. So vector. Okay, so vector is an ordered a list of number. Okay, and it can be visualized as point in space or an arrow with with direction and magnitude. Direction and magnitude. So for an example, we can write it like vector is equal to 2, 3, 3 to 5. Okay. So this is how we can represent the vector. So, moving further, like what are the operation we can perform in the vector? Okay, so let me write it down. Vector operation. Okay, so first is like your addition. So add corresponding components. So in the addition, like we are adding corresponding elements. Okay. Uh, so for example, suppose if I will give you like one vector is 1 comma 2 vector A and vector v is equal to 3 comma 4, and I will ask you like tell me vector c which is equal to a plus b. Okay, so how gonna tell you me the answer of c? Okay, so nothing you have to do. So the output of this vector should be like in the 1 comma 2 matrix. So here one element come and here one element come, and what element should be come? So we will decide it. So we will write it like 1 comma 2 plus 3 comma 4. Okay, and you have to add this element to the this element, and you have to add this element to this element, and you have to write it. Okay, so first like your 1 and 1 2. So 1 comma 1 1 comma 1 will be added to 1 comma 1 of the matrix, other matrix, whatever it is given. So basically it is a matrix only. So 1, 2 and 1. Okay. So 1 comma 1 will be added to the 1 comma 1. So what is 1 comma 1? 1 plus 3, which is equal to 4. So here the first element will be 4, and the second element will be like 1 comma 2, 1 comma 2. So 1 comma 2, what's the value for? 1 comma 2 is 2. And in the second one, what is the value of 1 comma 2 is 4. Okay, so when you will add it, so 2 plus 4 is equal to 6. So here you will write like 6. So the C vector will be like 4 comma 6. Okay, so I hope this is clear. So the next one is your scalar multiplication. Okay, so the next one is scalar multiplication. So what it means? So in this we are multiplying each element by a number. Okay, so what it means, let's take an example and we'll understand. So suppose there is one matrix is given to you like 1 comma 2. Okay, and you have to multiply it by some numbers. Okay, so suppose you have to multiply it by 5. Okay, so how you will write like 5 into 1 comma 2. Okay, so what is the output? Like this will multiply by a 1 comma 1, and again it will multiply like 1 comma 2. Okay, so what comes in the first one? So it will come like 5, and when 5 into 1 like 5, and 5 into 2 like 10. Okay, so the output will be like 5 comma 10. I hope this is clear. So the next one is your dot product. Okay, so dot product. So dot product, or you can say like your inner product. Okay, inner product. So both are same. Okay, so both are the same thing only. So for the dot product, the formula is we are writing like a dot b. A dot b is equal to summation of I is equal to 1 to n and ai comma bi. Ai bi. Okay, so this is the formula for the dot product. Okay, so just take an example and understand like what it is. Okay, so suppose for example one matrix is given like A is equal to 1, 2, 3, and B is given like 4, 5, 6, or you have to find like A dot B. Okay, so how you are gonna to find that? Okay, let's see. So first of all you have to multiply each element. Okay, so this element will multiply by 4, 2 will multiply by 5, and 3 will multiply by 6. Okay, so how we will write like, so A dot B is equal to 1 comma 1 into 4 plus 2 into 5 plus what it is 3 into 6. Okay, so we will write the value like 4 plus 10 plus 18. What comes? 32. So 32 will be the value of the A dot B. So this is how we are finding the dot product. So moving further, which is norm. Okay, in the fourth one, it is norm. So norm is basically the length of your vector, or you can say like length of vector. Okay, so let's see the formula first. So norm is represented like this, like double mode. Okay, so norm and its formula is like root under v1 square plus v2 square plus v3 square and dot dot vn square. Okay, so if suppose there is one vector given like 3 comma 4. Okay, and we have to find the norm for this. So how we can find it? Like is equal to 3 chi square plus 4 chi square. Okay, so how it will be like now 9 plus 16 root under which is equal to 5. 25. 25. and 25 root like 5. Okay, so this is how we are finding the norm. So the next topic is your matrix. Okay, so we'll discuss now like what is matrix and their operations. So the matrix is your, you can say like a matrix is a rectangular arrangement of a number in a row and column. Okay, so whenever you have seen the matrix, it looks like something this. So this is a rectangular representation, and here in this we are arranging some numbers like, okay, in the row and column. So this is your row and this is your column. So the best trick is to remember like what how we can remember like this is row and this is column. So suppose row is written like this and column is like this. Okay. So this part is your column and this part is your row. Just for basic understanding, guys. Okay, for remembering the things. Okay, just little bit this is trick. Okay. So I have seen like what is row and what is column and what is matrix. Okay. So the first rule is like a special matrix. So a special matrix like the identity and the diagonal are very useful. Okay. And the transpose flips the row into column. So suppose you have to find the transpose of some matrix. Okay. So this is A11, A12, A21, A22. Okay, so you have to find the transpose of this. So A is equal to itna. So A transpose you have to find. So how you are going to write that? A transpose is equal to row become column and column become row. So this become like this. So A11, A21, A12, A22. So this will be its transpose. Okay. And matrix multiplication is the fundamental or the foundation of machine learning, you can say, but not, it's not an element wise, it is follows row cross column rule. Okay, so when you have to find the matrix multiplication, it follows like row cross column. So by the element, like you are not multiplying this element to the respective element like that. Okay, it follows some rules, so we will understand this one also in detail. So let's take an example like if there is like 2 cross 2 matrix. Okay, suppose 2 cross 2 matrix is given and there one is one matrix, this is one matrix and this is one matrix and we have to multiply it. Okay, so what should be the outcome? Just think the output matrix what should be? It's row and column. Okay. Okay, now I'm not going to tell you this all things. We will go in the notepad and understand it in detail. So just take a pause and just search for it. Okay, you have multiple sources available like Google and some other things. So just search it and then come to my video. Then resume your video and just continue. Okay. So let's go to the notepad. I think this is basic, so we'll go to the notepad for the better understanding. So let me open it. So let me write down the topic name, which we are going to cover is like matrix. So the definition of matrix, you can say like a matrix is a rectangular array of numbers arranged in a row and column. Okay. So for example, a matrix, as I have told, like it is represented like 1, 2, 3, 4, like that, or you can say like 5, 6. So this is how a matrix is represented. So the first operation we will see on the matrix, like matrix operation. So the first one is your transpose. So transpose is represented like A transpose, like this, A cup over T. So basically in this we are flipping flip rows into columns. Okay, so for example, transpose is right 1, 2, 3, 4. This is your matrix given. So you have to write it like 1, 3, 2, 4. So what basically happens here? So suppose this is 1. Let me change the color. 1, 2, 1, 2. Okay. So what is the indexing of this? A 1, 1. Suppose this matrix is given like A 1, 1, A 1, 2. A21, A22. Okay, so this is your matrix. So, how it will get flipped? So, when you will take the transpose, A is equal to this much, and when you take the A transpose, so it will be like A11, okay, and A21, okay, and A12 and A22, okay. So, I hope I am clear with the transpose of a matrix. So the next is your matrix addition, like a scalar multiplication. So let me go to the next page. So the next is like matrix addition, matrix addition. So or and scalar multiplication, scalar multiplication. So in this, like the element wise addition and multiplication. Okay. So for example, suppose there is one matrix like 1, 2, 3, 4, and another matrix is like 1, 2, 3, 4, 5, 6, 7, 8. So you have to like just add it. So how you are going to add this? So 1 plus 5 will be your 6, 2 plus 6 is equal to 8, 4, 3 plus 7, 7 plus 3, 10, and 8 plus 2, 12. So this is going to be the output for this one. Okay, and the same thing like the multiplication also, if 1, 2, 3, 4 is given and you have to multiply it by 2. Okay, so what is the output? 2 into 1 2, 2 into 2 4, 2 into 3 6, 2 into 4 8. Okay, so this is your nothing but the matrix addition and a scalar multiplication. Okay, so I hope this is clear. So next to move on the matrix multiplication, okay, which is the main thing in your competitive exam. You are asked to multiply the matrix. So matrix multiplication. Okay, so the rule is like, suppose there is one matrix given m cross n, and there is one another matrix is given like n cross p. Okay, so always remember the one thing, like this one and this one will be the same. Okay, if both are the different one, suppose 4 cross 3 and 3 and here like 4 cross 5. So you can't multiply this. Okay, this can't be happen. So always your M, suppose M cross N matrix and is given, and second one is N cross P should be there. Like these two elements should be same. Otherwise, the multiplication cannot be done. Okay. So here the rule says like the output of the matrix, the output for this matrix will be like in the form of M cross P. Okay, so I hope this is clear. This is nothing but your row and column. This is your row and column, and this is your row and column. Okay, so I hope I'm clear with the matrix multiplication rule. So for the better understanding, let's take an example. Okay, so suppose there is one matrix is given like 1, 2, 3, 4, and you have to multiply it with like 5 into 6, 5 and 6. Okay, so how you are going to multiply? So just write it first, like this is 2 into 2 and this is 2 into 1. Okay, okay. So here we will do like the output should be in the form of like 1 into 2 into 1 matrix. Okay, so because this and this are same, so output will be like 2 into 1 matrix. 2 into 1 matrix. So this is how we have got the output. Like the output should comes into the 2 into 1 matrix. That much I have understand by the rule. Okay. So sorry guys. So now we will see like how we can multiply. Okay. So row and column. Row and column you have to multiply. Like 1 into 5 plus 2 into 6. 2 into 6. Okay. And the second one will be 3 into 5 plus 4 into 6. So see how it happened. Like row, you are going uh, you are going to this row and this column. Okay. So row and column. So 1 into 5 plus 2 into 6 plus this is the first one. This is your first one and the second will be like 3 4 na. So 3 into 5 and 4 into 6. So I hope you get to know like how we are doing. So let me remove this all parts. Yeah. So tell me the answer. 5. What is the answer? 5 plus 12, which is 17, and this one 15 plus 24 will be 39. So the answer of this like 17, 39, 2 cross 1. So this is your answer. Okay, I hope I am clear with this one. So let's move to the next one. In the matrix, the next thing is your something like identity matrix. Identity matrix. I think like you have heard about this somewhere. So this is denoted by I. So in your class 12th standard, I think this all things has already covered identity matrix, inverse matrix, and all. Okay. So don't worry, I'm going to cover that all things. You don't have to worry about much. So uh, identity matrix acts like number one in multiplication. I hope you have not get this. Let's take an example. So I is equal to 1 1 0 0. Okay. So the always the diagonal element of any matrix will be 1 and rest of the element will be 0. So this is called the identity matrix. Okay. Or you can write like A. There is your in one matrix like A, and when you will multiply with I, identity matrix will be your A only. So this is the like you can say this is you can say like one of the property of your matrix. Okay, I hope this is clear. So moving further, which is like inverse of a matrix. Okay, So next thing is like inverse of matrix, inverse of matrix, or you can represent it like A inverse. Okay, so will not take much time. So if it exists, if there is one matrix which is inverse, so it follows one rules, which is A dot A inverse is equal to your identity matrix. This is one of the most used property in the matrix. Okay, so A into A inverse will be your identity matrix. So I hope I'm clear with the basic understanding of the matrix. So now we will move further to the linear algebra in machine learning, which was our today's motto to understand. Okay, so the linear algebra in machine learning. So in this machine learning, like a data set is usually represented as a matrix, and each row in one data sample and each column is a feature. Okay, so each row is equal to sample and each column will be like features. Okay, so the weight we can learn usually stored in a vector. So the prediction are made using the matrix vector multiplication. Suppose, for example, in a linear regression, the prediction is simply the dot product of the input features and weight vectors. So, this shows how linear algebra is at the heart of machine learning algorithm. Okay. So, for understanding it in detail, so I have to go to the notepad. So, let me open it. So, yeah. So, the next thing is like linear algebra. Linear algebra. So basically in this, the first thing came is your data representation. Okay, so in this, suppose there is one data set with 100 sample and 10 features. So it is stored as 100 into 10 matrix. So I hope I am clear. So the next key point which you should know, like linear regression, sorry, regression is nothing but your prediction formula. For the linear regression, the prediction formula is like prediction formula is your y is equal to xw. Okay, so the next is like your neural networks. So before moving that, we will just write the equation y is equal to xw plus z. Okay, so z is your constant. So x is the variable and w is the weight. Okay, so I hope this is clear. So the last thing which we have like left with is your neural networks. So each layer is your computation is equal to matrix multiplication, like input weight and inputs into weight. So you can say like each layers each layers computation happens in the neural network and it happens in the matrix multiplication form. Matrix multiplication multiplication form. So how we are multiplying a matrix? Like input into weight. If we talk about in the concept of machine learning. Okay. So neural, let me change the color, neural network. So the next one is your example, you can say like image. So it is stored in the 2D matrix or a pixel value, or you can say 3D for RGB color. So initially we have like black and white image. Okay. So it was stored in the 2D matrix. Okay. It was stored in the 2D matrix in the form of like pixel value. Now the colorful images comes in the picture. So this is nothing but your RGB images, you can say, and it is stored in the 3D like matrix, okay, or in the 3D value or 3D dimension. So this is all about the today's video. Let's take a quick example for everything what we have did. So suppose data set is like x is equal to 567 and here is like 60, 65 and 70. Okay. So and the weight is equal to like 0.5 and 0.3. So the prediction prediction is equal to what? X into weight, which is W. Okay. X into W. Okay. So the Y is equal to XW as I have seen. So how we are going to find this? So it will be like 5 into 0.5 plus 60 into 0.3 and 6 into 0.5 plus 65 into 0.3 and 7 into 0.5 plus 70 into 0.3. So just match from here. Okay. Row into column, row into column and row into column. Okay. So I hope this is clear. So what is the output for this one? 20.5, 22.5 and 24.5. Your prediction, Y value, which is your prediction. So this is how linear regression makes a prediction using the vector and the matrix. Okay. So in this video, we have learned like vector represent the features and in the directions, and matrix represent data sets and the transformations, and operations like dot product, norms, and matrix multiplication are the backbone of the machine learning model we have already seen. And we also saw like how linear algebra helps in data storage and model computation like linear regression and neural nets, and similarity and distance measurement we have also seen. So this is about the today's video. So in the next video we are move to the further topics. So thank you guys, thank you very very thank you for attending this whole session. So a whole session what I have taught you, like it comes a positive benefits for you only. So with this hope, I am winding up with the today's lecture and see you in the next, in which we are coming with the next concept. Okay. So tab tak ke liye keep learning and keep exploring. See you in the next video. Bye bye.